Hello, my dear students. Good evening because it's evening here, and today we will be going to study motion in one dimension. This branch is actually in physics known as kinematics. Some of you have heard this word because the word dynamic, static, these are actually regular words which are being used in day-to-day life. But this word kinematic, some students may know or some student may not be knowing this word. But what does this sentence mean, this word mean? Kinematics mean the branch of physics which deals with the study of motion without considering the cause. Like, suppose there is a stone and we put some force on it. Like, then this stone will move in this direction, right? So the stone is at rest now, and when we will apply some force on this stone, it will move, say, up to this position. So from here to here, this stone was in motion. So without knowing the force behind it, the cause behind the motion, we only take interest in the motion of the object, right? Then this branch of physics is known as kinematic. Okay, so in kinematics we have different topics, but first topic is like scalar and vector quantities. Okay, next is distance and displacement. Then we will also study about speed and velocity, right? Then if we have time to cover all these things in one lecture, then probably we must be doing some sort of numerical problems also. If not possible in today's lecture, we will do it in next lecture for sure, right? So what are scalar and vector quantities? Physical quantities you might be knowing. What is a physical quantity? Any quantity which can be measured, right, is a physical quantity in a particular unit. Like if you go to a shopkeeper and you want to buy sugar, then what will you say? Will you say, give me 2 liters of sugar? No. You will say that please give me 1 kilogram of sugar. So now 1 kilogram mean 1 is the quantity, or you can say number or magnitude, whatever you say. Magnitude mean numerical value, right? We will be using this word magnitude, which is nothing but numerical value. So this 1 is the numerical value or the magnitude, and this kilogram is the unit to measure. Which quantity? Now this quantity is nothing but weight, right? Actually, there are two things. One is mass and other is weight. Both are physical quantities, right? There is a difference between mass and weight. When we will go for another lectures like in gravitation, then I will tell you what is the basic difference between mass and weight. Generally people in layman language say mass and weight are same. No, mass and weight are not same. So this is one physical quantity, right? Another physical quantity may be, say, pressure. Pressure is a physical quantity, right? Speed is a physical quantity. Velocity is a physical quantity. There are a lot of physical quantities which are dealing with the motion, right? So the physical quantities are basically characterized by two parameters, two characters actually. One is scalar character and other is vector character, right? So those quantities which have only magnitude, no direction is required to specify them. If we want to state some quantity, that this is this quantity, then if we do not require direction, we require only magnitude, then that quantity is called as scalar quantity. So in scalar quantity, only magnitude is required to specify that quantity. Example, simple example, distance, speed. Let me tell you, speed and velocity are different. I will tell you today what is the difference between them, but for the time being, speed is a scalar. Okay. Then, if we come to vector quantities, what are vector quantities? Vector quantities are those which can be characterized, which can be described by the magnitude as well as direction. So, if a quantity can be expressed by magnitude as well as direction, then we call it that vector quantity, right? So vector quantities examples are velocity, okay, then force, of course, then acceleration, and so on. There are a lot of vector quantities. Like if you say a force is applied in a direction to the direction of motion. So when I'm saying a force is applied in a direction, so it means direction is required to specify that force. And also there is magnitude, because when I will say 10 Newton is applied parallel to or perpendicular to x-axis, right? So it means direction is required now. Without direction you cannot say force is applied. If you say bluntly force of 10 Newton is applied, it's a wrong statement. You have to specify the direction only. So those quantities which require magnitude as well as direction to completely specify them, to completely characterize them, then these quantities are known as vector quantities. Is that clear? Very simple. Okay. So after the discussion of scalar and vector quantities, we will be moving towards distance and displacement. Generally people say distance and displacement are same, but it is not so. Why? Let me explain. When I say distance, so to explain distance and displacement, let us take one example. Suppose a person is standing here, say at point A, right? Then the person reaches here at point B after walking through this some distance, some length, right? So this is 2 kilometer, 4 kilometer, 6 kilometer, 8 kilometer, 10 kilometer, and say it is 12 kilometer, right? The scale is in kilometers. Person is standing here. Okay. Now this person moves along this direction, right? So what is the distance? When I say person moves from A to B and then it comes back from B to A, right? It goes here and then come back here. Like if you go from Abu Dhabi to Dubai and then Dubai to Abu Dhabi back, or in Indian Diaspora, we say we go from Ambala to some village, nearby village, Babyal, and then from Babyal to Ambala back, right? So, what is the path length? Simple question to audience. What is the path length from A to B? Any person can tell it's 12 kilometer, right? Okay, path length from B to A, again 12 kilometer. So total path length from A to B and B to A combined is 12 plus 12, 24 kilometer. Now do you know what? When the person moves from A to B and then he or she comes back from B to A, then the total path length covered by the person is 24 kilometer. You know what? This total path length is nothing but distance. This is distance. Now you will be surprised by my next words, next sentences, where I will prove that displacement is different from distance. Generally people say distance and displacement are same, but no. In physics, distance has a different meaning than displacement. So now we come to displacement. You know what is displacement? Displacement is the shortest distance between the final position and the initial position. So displacement equal to final position minus initial position. Okay, tell me, when a person goes from A to B, okay, and then he comes from B to A, what is the initial position? A. What is the final position? A, because he has gone from A to B and then B to A. So what is displacement? 0 kilometer. Now this is somewhat strange. Distance from the same length is 24 kilometer for to and fro motion. But for to and fro motion, displacement is 0 kilometer. This is the beauty of physics. So we can define distance as the total path length covered by an object under motion. And what is displacement? It is the shortest distance between the final position and the initial position. Right? Can you tell me some other example where displacement is 0 but distance is not 0? Yes. One example I remember when I was in 11th class in Khalsa College, Yamuna. My teacher used to tell me this example and I remember from that time. Suppose a person is here. You can see this dot, right? Now he travels like this, then like this, and then like this. Say A, B, C. Okay? From A to B, say he covers 2 kilometer. From B to C, say he covers 3 kilometer, and from C to A, say he covers 4 kilometer. Random I have chosen the values. So what is the path length? Now the path length in this case is AB plus BC plus CA, which is 2 plus 3 plus 4, 9 kilometers. So this 9 kilometer is nothing but distance. Okay? Now what is displacement in this case? Very simple. Person starts from A, goes to B, B to C, then C to A. What is the initial position? A. What is the final position? It comes back to A. So final position is same, A. What is the displacement? Again, displacement is 0. So from this we conclude that there are 3 to 4 major differences between distance and displacement. Let me tell you. Number one, when you are given a question like this, state 4 differences between distance and displacement. You simply have to give this example, right? Then you can state the differences. Don't cram physics actually. Try to learn the methods, try to learn the words, try to learn the terminology used in physics. Then you will fall in love with physics actually. Okay, people fall in love. That is a normal phenomena because we are humans. But falling in love with physics is somewhat much bigger than falling in love with humans. Okay, so this distance and displacement, we have 3 to 4 differences. Number one is always when you are asked some difference, give the definition, right? Because definition will be different. So you can say distance is the total path length covered by an object during its motion. What is displacement? It is the shortest distance between final position of the object and initial position of the object, right? Second is distance is a scalar quantity. I told you distance is scalar and displacement is vector. Okay, now third difference, distance is always positive, right? But distance can never be 0. Mind it, distance can never be 0, but displacement can be 0. Have 3 differences. Now fourth difference is distance depends upon the value, the path chosen, not value, depends upon the path chosen, how it is measured. Like if this is the path, distance will be different. If this is the path, distance will be different. But as far as displacement is concerned, it do not depends upon the path, because it do not depends upon path actually. It do not depends upon path length actually. It depends upon the initial and final position. That is why displacement do not depends upon the path chosen to measure the quantity, right? So if you, in case of distance, it will be different here, like this plus this plus this plus this. Okay, you are coming to A, say it is A here in this figure. So you are going like this and then you are coming like this, and here again you are going like this and you are coming in only 3 steps, 1 2 3. Here in 4 steps you are coming back to A. But if you measure distance, it will be this plus this plus this plus this, total path length. Here measure the distance, this plus this, 3 times only distance will be there, path length. So distance will be different because now it depends upon the path chosen, type of path you have chosen to measure the distance. But displacement will not depend upon this, because displacement depends upon initial and final. Now initial position is A, final is A, 0. Initial is A, final is A, 0. So displacement do not depend upon the path chosen, right? So our next topic is what is uniform and non-uniform motion. We will try to understand it with the help of some example. Like, so what is uniform motion? Okay, before going into the typical definition which are given in the books or internet, let us take example. Say we have time and one person, say Jasveer, and one person is say JP Singh, right? Jasveer Singh at 9 a.m. covers distance 0 kilometer and JP Singh also 0 kilometer. Okay, so distance covered by JP Singh and Jasveer, right? Say at 9:30 a.m. the distance of Jasveer is 10 kilometers and distance covered by JP Singh is say 6 kilometers, because JP Singh stops somewhere, right? When going along with this Mr. Jasveer Singh, JP Singh stops somewhere. Okay. Now at 10 a.m. Jasveer Singh covers a distance of 20 kilometer, and when we see the distance covered by the path length covered by JP Singh, it is say 12, not 12, it is 20 kilometers, not 20, take something else, 22 kilometers. Now at 10:30 a.m. Jasveer Singh goes and covers 30 kilometers, okay, up to 10:30 a.m. and it covers 25 kilometers. Say at 11 a.m., which is the end of their journey, let us suppose it covers 40 kilometers and it covers say 28 kilometers. Now it is clear from this data, this is a very important data. Actually every data interprets something. No data is blank. Whenever you have been given a data, you have something hidden in that, and it's your mind and intellect which can get something from that data, right? From this data, just look at this. What is the time interval? At 9 a.m. Jasveer Singh covers 0 kilometer. It means he was at rest. After 30 minutes, he covered 10 kilometer. Then again after 30 minutes, he again covered more 10 kilometers. Then again after 30 minutes, he covered more 10 kilometers. And then again after 30 minutes, he covered more 10 kilometers. So, Jasveer Singh is covering equal distances in equal interval of time. What is the time interval? 30 minutes. In each 30 minutes, Jasveer Singh is covering 10 kilometer, 10 kilometer, 10 kilometer, 10 kilometer. So, this type of motion is called as uniform motion. Simple. So, what is uniform motion? An object is said to be in uniform motion, or an object is said to possess a uniform motion if it covers equal distances in equal interval of time, like Jasveer Singh did. Now let us see about JP Singh. He is a lazy man. He is far behind Mr. Jasveer Singh. Let us see why. At 9 a.m. he was at rest. He didn't cover anything like Jasveer Singh, no problem. But after 30 minutes, he covered 6 kilometers. Then at 10 a.m., mean in again next 30 minutes, he covered 22 minus 6, 16 kilometers. Then 10 to 10:30, in the next 30 minutes, JP Singh covers only 3 kilometers. Ridiculous. Then in 10:30 to 11, mean in the next 30 minutes, JP Singh covers only 3 kilometers. So, this type of motion, we see that JP Singh is covering unequal distances in equal 30 minutes in equal interval of time. So this is non-uniform and this is uniform. So what is non-uniform motion? JP Singh is in non-uniform motion and he is covering unequal distances in equal interval of time. Time interval is same, 30 minutes for each Jasveer Singh and JP Singh, but he is covering equal distances in each 30 minutes and JP Singh is covering unequal distances, sometimes 6, sometimes 16, sometimes 3. So JP Singh is in the non-uniform motion. I think it is clear. It is very simple. Let us see if we can draw a graph of this. Okay. Let us draw a simple graph to understand this. And I will tell you something when I will draw a graph. Okay. That is very important. Here we take time. Many students can arise a question. Sir, why do you take time on this axis, x-axis always? My dear students, there are two types of quantities in whole universe. One quantity is called dependent quantity and other is called independent quantity. Okay? Dependent quantities are those which depends upon these independent quantities. Here I will write distance. Okay? You see, distance is depending upon time. At this time, distance is this much. At this time, distance is this much. Time is not depending upon anything. That is why time is independent. And distance depends upon this time. That this distance is this much at this time. This is distance is this much at this time. Then it means distance is depending upon this. So time is independent here and distance is dependent. And any independent quantity is generally taken on the x-axis. In few cases we can take it, we will discuss it later, but generally the independent quantities are taken along the x-axis. Always remember. So let us draw a graph. Time is 9. Just put here 9 a.m. equal interval 9:30. Then same 10. Then same 10:30. Then same 11. Okay. Here the scale is 0 to 40. 0 to 40. So 10, 20, 30, 40. So at 9 a.m. it was 0 here. At 9:30, Jasveer Singh 10. 10. This is 10. This is 9:30. So you take this. You can remove this. Okay. Now at 10 it was 20. 20 and 10. Here they meet. Put a dot. 10:30, 30. So 30. Simple graph which you make at home many times. 11, 40. Now join these. What did you see? What did you see? This graph is a straight line. So always remember one tip, one point which has to be committed to memory. That is, whenever one quantity varies directly with the other quantity or the two quantities are in uniform motion, then their graph will be a straight line. Always. Graph will always be straight line only for uniform motion. Right? If we draw the graph for JP Singh, it will be somewhat different. At 0, it is 0. At 9:30, 6 kilometers. 6 is here. 10, 22, 10, 22, and 10, 30, 30 here again, and 11, sorry, not 30, 25, sorry. So at 10:30 it is 25. We are drawing graph for here. 25. 25 is here. Okay, then 11, 28. 11, 28. 28 is approximately here. So this is the graph for JP Singh. This is Jasveer graph, uniform motion, and JP Singh non-uniform. Right? It's simple. Thank you.